Greetings. It is a profound privilege to welcome you on behalf of Analysys to this exploration of the truly remarkable. Our planet, a vibrant sphere teeming with life, presents an endless pageant of evolutionary marvels, creatures great and small, each with its own extraordinary story. Often the most astonishing truths are hidden in plain sight, within the very fabric of the beings with whom we share this world. We may think we know them, these familiar denizens, yet they hold secrets that can reshape our understanding of what it means to be alive, to adapt, and to thrive in a universe of constant challenge and breathtaking ingenuity. Today, here at Analysys, we embark on a journey to uncover some of these hidden wonders. We shall delve into the intricate designs and peculiar habits that make the animal kingdom a source of perpetual fascination. Prepare to witness the elegance of adaptation, the surprising twists in evolutionary pathways, and the sheer, unadulterated chi-miao wonder marvel of nature's creations. These are not mere trivialities, but windows into the complex, interconnected web of life that sustains us all, offering insights that are as humbling as they are enlightening. Welcome to our channel. Today, we're diving into the fascinating world of animals. Here are the top 10 amazing facts about animals that will blow your mind. Don't forget to like, share, and subscribe. It is through this shared curiosity and appreciation that we can all contribute to a deeper understanding and indeed a greater respect for the natural world in all its diverse splendor. Join us as we peel back the layers of the ordinary to reveal the extraordinary that lies beneath. Consider, if you will, the humble shrimp. A creature often perceived merely as a delicate morsel from the sea, or a tiny scuttling inhabitant of rock pools and coral reefs. Yet, within its translucent frame lies an anatomical arrangement so counterintuitive, it challenges our very assumptions about biological design. For the heart of a shrimp, that vital organ responsible for propelling life-giving fluids, is not nestled within its thorax, as one might reasonably expect, following the pattern of so many other creatures. Instead, this critical pump resides, quite astonishingly, within its head. This cephalic placement is a remarkable testament to the diverse solutions life devises. This unusual positioning is not a mere quirk of nature, but a sophisticated adaptation. The shrimp's head, or more accurately its cephalothorax, is a hub of vital functions: sensory organs, feeding apparatus, and, crucially, the gills through which it extracts oxygen from the water. Placing the heart in such close proximity ensures the most efficient delivery of oxygenated hemolymph directly to the brain and other critical cephalic structures. It is a masterstroke of evolutionary engineering, a compact and highly effective system that underscores how form and function are inextricably linked, even in the smallest of beings, ensuring survival in their watery realms. The snail, a creature synonymous with a leisurely pace, a symbol of unhurried movement across garden paths and forest floors, possesses another, far more extreme temporal adaptation. While its daily progress might be measured in inches, its capacity for dormancy extends into years. It is a scarcely believable feat, yet true. A snail, under certain conditions, can enter a state of profound slumber that can last for up to 3 entire years. This is not mere rest, but a deep metabolic shutdown, a suspension of active life in response to environmental adversity. This extraordinary ability, known as estivation when triggered by heat and dryness, or hibernation in colder climes, allows these gastropods to endure periods when food is scarce or moisture is critically low. They seal the aperture of their shell with a hardened layer of mucus called an epiphragm, effectively creating a personal, self-contained survival chamber. Within this refuge, their heart rate plummets, respiration slows to a barely perceptible level, and all non-essential bodily functions are curtailed. It is a strategy of profound patience, a biological waiting game, allowing them to outlast harsh conditions and re-emerge when the world outside once again becomes hospitable to their gentle way of life. Elephants, the largest terrestrial animals on our planet, command a presence of immense power and gentle dignity. Their colossal frames, supported by pillar-like legs, move with a surprising grace across the savannas and through the forests they call home. They can run, swim, and navigate complex terrains with remarkable agility for their size. Yet, despite their strength and muscularity, there is one simple feat of locomotion entirely beyond their capabilities: Elephants are the only mammals that cannot jump. All 4 feet never leave the ground simultaneously in a true leap. This seemingly peculiar limitation is a direct consequence of their massive size and unique skeletal structure. Their leg bones are aligned in a remarkably straight column designed to support their immense weight rather than to provide the spring-like action required for jumping. Furthermore, their ankles possess limited flexibility, and their sheer body mass would make the forces involved in launching and landing such a jump biologically prohibitive and potentially injurious. Their method of locomotion, an ambling gait where at least 1 foot is almost always in contact with the ground, is perfectly suited to their needs, a testament to how evolution shapes abilities according to the specific demands of an animal's scale and lifestyle. Chapter 4. The rhinoceros, an ancient and formidable creature, carries upon its snout one of the most iconic and tragically coveted structures in the animal kingdom, its horn. For centuries, this imposing appendage has been shrouded in myth and misunderstanding, often perceived as being composed of bone, akin to the antlers of a deer or the horns of cattle. However, the reality of its composition is altogether different and perhaps even more fascinating. The rhino's horn is not bone at all, but a dense mass of compacted keratin fibers. This keratin is the very same protein that constitutes human hair and fingernails, as well as the claws, hooves, and feathers of other animals. The horn grows continuously from its base at the skin, much like our own hair, and is essentially a tightly matted aggregation of these hair-like filaments, cemented together by glandular secretions. Understanding this composition is crucial, particularly in light of the devastating poaching crisis driven by the fallacious belief in the horn's medicinal properties. It is a marvel of biological engineering, yes, but one made of the most commonplace of materials, a fact that starkly highlights the senselessness of its pursuit. Chapter 5. Frogs, those agile amphibians with their powerful hind legs and watchful eyes, are typically creatures of quick reflexes, ever ready to leap to safety or snatch an unsuspecting insect. Yet there exists a peculiar phenomenon, a way to induce a state of temporary profound stillness in these normally active animals. It is said that one can, in effect, hypnotize a frog by carefully placing it on its back and then gently, rhythmically, stroking its stomach. The frog, rather than struggling, may become remarkably placid, its limbs relaxed, entering a trance-like state. This curious response is not true hypnosis in the human sense, but rather a natural behavior known as tonic immobility, or sometimes thanatosis, feigning death. It is believed to be an anti-predator defense mechanism. When a frog finds itself in a vulnerable position, such as being overturned by a predator, this state of apparent lifelessness can sometimes cause the attacker to lose interest, perhaps perceiving the frog as already dead or unpalatable. The gentle stroking might mimic the sensation of being held by a predator, triggering this innate passive defense strategy. It is a fascinating glimpse into the subtle and often surprising survival tactics employed throughout the animal world. Chapter 6. The domestic cow, Bos taurus, is an animal inextricably linked with human civilization, a gentle provider that has nourished populations for millennia. We are familiar with its daily offerings of milk, a staple in countless diets across the globe. But when one considers the cumulative production of a single cow over its entire lifespan, the figures become truly staggering. A healthy, productive dairy cow can yield nearly 200,000 glasses of milk in its lifetime. This is a veritable river of sustenance, a testament to the remarkable biological efficiency of these animals. This extraordinary output is the result of centuries of selective breeding coupled with careful husbandry and nutritional science, all designed to enhance a natural maternal function. The physiological demands on the cow to produce such vast quantities are immense, requiring significant energy and nutrient intake. Each glass represents a small part of a continuous biological process, a transformation of simple forage into a complex, nutrient-rich fluid. It is a quiet miracle of agriculture and biology, one that underscores the profound symbiotic relationship that has developed between humans and these generous, unassuming creatures. As twilight descends and darkness begins to cloak the landscape, caves across the world become portals for an extraordinary exodus. Bats, those masters of nocturnal flight, emerge in their thousands, sometimes millions, to forage under the cover of night. In this mass departure, an intricate ballet of wings and echolocation, observers have noted a peculiar, almost ritualistic behavior. When leaving a cave, bats consistently, or at least predominantly, favor turning to the left. This subtle, yet seemingly ingrained tendency is a curious detail in the life of these fascinating mammals. The precise reasons for this directional preference remain a subject of ongoing scientific inquiry and debate. Several hypotheses have been proposed. Perhaps it is related to the Earth's magnetic fields or the Coriolis effect influencing their initial trajectory. It could be a strategy to avoid mid-air collisions in crowded cave exits, a kind of natural traffic rule. Some researchers suggest it might be linked to brain lateralization, similar to handedness in humans, where one side of the brain, and thus one direction of movement, is dominant. Whatever the underlying cause, this leftward inclination upon exiting their roosts adds another layer of mystery and wonder to the complex, hidden lives of bats. Chapter 8. The Silent Giants, Giraffes, and their unique vocalizations. The giraffe, with its impossibly long neck and gentle demeanor, is an icon of the African savanna, a creature of serene and lofty elegance. Its towering stature allows it to browse on foliage inaccessible to other herbivores, granting it a unique niche in its ecosystem. For a long time it was commonly believed that these magnificent animals were entirely mute, lacking the vocal cords necessary to produce sound. This image of a silent giant moving gracefully through the acacia woodlands has been a pervasive one. However, more recent and dedicated research has begun to unveil a more nuanced reality. While giraffes do not possess vocal cords in the same way as, say, a roaring lion or a chattering primate, and thus lack a complex vocal repertoire, they are not entirely silent. They can, and do, produce a range of subtle sounds: hisses, snorts, moans, and most intriguingly, low-frequency infrasound calls, largely below the threshold of human hearing. These infrasonic hums, often produced at night, are thought to play a role in communication over long distances, allowing these dispersed animals to maintain social cohesion. So, while not vociferous, the giraffe communicates in ways we are only just beginning to understand. Chapter 9. Forward Momentum, the kangaroo's one-way locomotion. The kangaroo, Australia's most famous marsupial, is renowned for its extraordinary method of locomotion, powerful bounding hops that can propel it across the landscape at considerable speed. Its massive hind legs, enormous feet, and long, muscular tail, used for balance and as a third limb when standing, are perfectly adapted for this energy-efficient means of travel. This specialized anatomy, however, comes with a peculiar constraint. Kangaroos find it virtually impossible to walk or hop backwards. Their forward momentum is, in a very real sense, irreversible. The sheer size and musculature of their legs and tail, so advantageous for forward propulsion, become an impediment to reverse movement. The structure of their feet and the way their legs articulate are simply not designed for pushing backwards effectively. To move in reverse, a kangaroo would have to engage in an awkward, uncoordinated shuffle, a far cry from its fluid forward leaps. This inability to retreat easily underscores how highly specialized adaptations, while providing significant advantages in one context, can impose limitations in others, shaping an animal's behavior and interaction with its environment in profound ways. Chapter 10. A Matter of Vision, the ostrich's eye and brain. The ostrich, the world's largest and heaviest bird, is a creature of superlatives. It lays the largest eggs, can run at speeds surpassing many mammals, and possesses a gaze that seems to survey its vast open habitat with keen awareness. But perhaps one of the most startling facts about this flightless avian marvel concerns the relative proportions of two of its most vital organs. Quite remarkably, an ostrich's eye is actually larger than its brain. Each eye can measure up to 2 inches in diameter, a truly enormous ocular structure. This seemingly disproportionate investment in eyesight over brain mass is a direct reflection of the ostrich's evolutionary priorities and the demands of its environment. Living on the open plains of Africa, where predators can approach from any direction, exceptional long-distance vision is paramount for survival. These large eyes provide a wide field of view and acute visual acuity. allowing ostriches to detect threats from afar, giving them precious time to flee. While their brain is appropriately sized for coordinating their bodily functions and behaviors, it is the imperative of seeing danger that has driven the extraordinary development of their visual apparatus, a striking example of adaptation shaping anatomy. And so our brief journey through these 10 facets of animal existence draws to a close. From the shrimp's cranial heart to the ostrich's discerning eye, we have glimpsed but a fraction of the ingenuity and sheer unexpectedness that life on Earth consistently presents. Each fact, a tiny thread in an immense and intricate tapestry, serves to remind us that the world around us is far more complex and wondrous than we might often perceive in our daily lives. The animal kingdom is a library of living stories, each species a volume filled with unique adaptations and evolutionary sagas. The pursuit of knowledge, the simple act of observing and questioning, continually reveals new layers of understanding. Here at Analysys, we believe that this curiosity is fundamental. There's always more to learn, more to discover, more to be astonished by in the natural world. These creatures, with their peculiar traits and surprising abilities, are not just curiosities. They are vital components of their ecosystems, each playing a role, each a testament to the enduring power and creativity of evolution. Thanks for watching. If you enjoyed these amazing animal facts, make sure to hit the like button, share this video with your friends, and subscribe to our channel for more incredible content. See you next time. May our shared appreciation for these wonders continue to grow, fostering a deeper connection to the planet and all its inhabitants. The book of nature is vast, and its pages are always turning, inviting us to read on.